Our next doodle is measurement units. The history of measurement units is interesting. I wish I knew more about it, but I've never found a great book. So a lot of this is just from Wikipedia. Carpentry and other crafts needed a standardized inch. That way, if you were building parts of a chair in your shop and I'm building other parts of the chair, like maybe you build the seat in the back and I make the legs or something, then it will all fit together nice. Whereas property issues don't need a lot of precision. If I'm wondering how much land is Josie's and how much is Jaden's, then you don't really have to fight too much about the details of where the fence is. So how do we get an inch accurate? So an inch was defined as the average value of the width of your thumb knuckle. A bunch of guys would get together in the middle of the town and measure their thumbs. And even if some people had big thumbs and some had small, by the time you took their average, then that would be about the same. So a carpenter in one town and a carpenter in another town could cooperate on projects. Yard, on the other hand, didn't even have a common definition. In some places it was 3 feet. In some places it was the average waist circumference. So wrap around your waist, how long is your belt? And in some places it was 2 cubits. So you can see in my camera, I am holding my arm elbow to elbow, my fingertips together. That's 2 cubits because 1 cubit is fingertip to elbow. So 2 cubits. By the way, a foot was 12 inches because people's boots were big and clunky. And that way you could walk heel toe, and measure out things in feet. That's why most people don't have actually 12-inch feet these days. A different system was the metric system. It was created in France beginning in 1791. They defined a meter as a 10 millionth of the distance from the equator to the North Pole. So imagine starting at the equator and hiking straight up the globe until you get to the North Pole. Now, the Earth isn't completely round. If one of you were to start hiking at the equator in one continent and the other at the equator in another continent and hike your way up, then you get different distances. So which line are you hiking? The one that goes through Paris, because we're French. And remarkably, the expedition that was sent to try and measure this was only off by a 50th of a percent. So there are tables on the screen about different measurement units. Some of them you might know already, like 12 inches in a foot. Some of them might be obscure, like a ton is 2,000 pounds. Some of them you might know if you are spending time in the kitchen, pints and cups and quarts, and other people wouldn't know that. There we go. The bottom table tells you how to go back and forth between the standard US units and the metric ones. Let's look at this a little more. So we're comparing 2 measurement unit conversion problems. The first is 2.5 feet, 2.5 feet is how many inches? So we know there's 12 inches in a foot. We're going to do something with 12. What are we doing with 12? So let's look at this. On your screen are 2.5 rulers. See, the bottom one is 6 inches. It's half of a ruler. So split that apart. Take your mouse and just break apart all these rulers into separate inches. How many inches do you get?
Don't know if we have enough room to like kind of split them all.
That's okay.
Oh, okay.
You can even take some and just kind of like move them way up over places.
Oh,
We don't
okay.
stay organized. We're just going to count them at the end. Okay, if we count them all, what do we get?
$30?
30. So when we split apart a measurement unit, we multiplied. If we didn't have the props, we could just do 2.5 times the 12 inches in a foot, and we'd get 30. 2.5 times 12 is 30. Can you see why the multiplying is happening? Why each foot turned into 12 times as many things? Okay, now we'll go the other direction. 18 inches is how many feet? Now we're sort of smooshing things together. Smoosh. So we're going to divide. If I did it without actually moving things, 18 divided by that 12, it's still 12 inches per foot. What would that be? 1.5. Let's see if this works. You want to assemble the rulers or should I?
I guess you could do it.
Both do it. Why don't I do the top one and you do the bottom one? 1, 2, 3, 4. There's a 4 for you. 5, 6, 7, 8. Well, there we go. 1 ruler and half a ruler. See how we got 1.5 feet out of the 18 inches?
Yes.
This chart up in the corner helps people who don't do a lot of kitchen baking. A gallon is the big thing. Its name is in the middle. A quarter of it is called a quart. That's why it's a quart, because it's a quarter. Each quart we break up into pints. So that would be 8 pints per gallon. 1, 2, 3, 4, 5, 6, 7, 8. And each pint we break up into cups. So there'd be 16 cups in the gallon. This is 4, and then we'd have 4 4s. They were all cups. So we know there's 12 inches in a foot, 16 cups in a gallon. Similarly, there's 16 ounces in a pound. So let's go through them first and tell me if we're multiplying or dividing. If we are taking something and shattering it into smaller pieces, we're multiplying. If we're taking something and grouping or smushing things together, then we're dividing. So for the first one, inches to feet, is that times or divide?
Times.
No, that's this one we just did. We're taking a bunch of inches that were loose on the page and smushing them together to make a ruler. So that one is divide. Going from feet to inches.
Times.
That's that one, right? We took the feet and we shattered it, we split it apart into lots of separate inches. So that one's multiplied. Okay, cups to gallons. If I had a bunch of little cups all over the place and I put them into a gallon, combining them all together, is that multiply or divide?
Divide.
Correct. Just like we were putting a bunch of little things together. We put cups into the gallon, we're putting things together. The other way, if I had a big gallon and I poured it out into lots of separate cups, which one is that?
Times.
Fine. If I had little ounces and I put them all together to be pounds, which one is that?
Divide.
Just like this one, we're putting little things together. And then if we had the bigger thing, the pounds, and we break it apart into ounces, that would be multiply, just like the breaking apart page. So now I could do all of these: 5.75, 198, 12, 40, 152, 152. For inches and feet, it's 12s. Cups and gallons is 16s. Ounces and pounds is 16s. Wait a minute. Inches. I'm sorry, I am falling asleep. I'm doing these backwards. I phrased things backwards. It confused me. I went from inches to feet. Inches is how many feet? Now we're going inches 2 feet this way. So all of these should be backwards. That was terrible on my recording. Okay, we're going from, I should change this so it matches, right? I want the froms to be here and the twos to be there. So I am wording my English very badly. Anyway, it should be times and divided. And from gallons, breaking it apart, that's going to be times. And from little pounds, from big pounds into little ounces, that's going to be times divide. Pounds is bigger when, yeah. I'm sorry, I messed up there. Okay, I should fix this page and do it again on Thursday because that was terrible. If I wanted to do these, I could, right? 5.75 times 12. 69. There we go. 198 divided by 12. 16.5. So I'm not going to go through and do all the calculator math, but you could do that. Okay, I'm going to put to myself a note, reword. And we'll do this again next time without me being confused. Okay, I've updated this picture about knowing which arithmetic to use in a word problem. Adding was when you combined 4 and 2, and now they're all hooked together. Removing was subtraction. We had 6, but we're taking away these 2, so there's 4 left. Counting beyond was also subtraction. We had 4. How many more do we need to do to get to 6? And that's 6 minus 4, and we have to take 2 more steps. Making copies was multiplying. And what we saw with the ruler was if we shatter things into pieces, that's also multiplying. If we select some things out of others with a fraction, that's multiply. What's half of 6? That's 3. And if we select with a percentage, that's also multiply. What's 50% of 6? That's 3. If we're grouping and clumping and smooshing things together, that was dividing, smooshing the ruler pieces together. Or if we make fractional pieces, if we have 6 things and 6 cakes and everyone gets half a cake, 12 people can get served. That's dividing. It looks the same, but we're saying different things. We're saying each of 6 pieces get shattered into 2, or we're saying each of 6 things get turned into a size 1/2. If we're building a fraction is division, just like we did with the probabilities. We were making fractions by looking at situations. And if we're building a percent, that's also division. We did the division step and then the ripple up with the probabilities. So we have a nice chart about when to use which operations. So try and explain that in your own words. You'll understand it better if you can put words to it. And I apologize again for not reading carefully. My math was okay, but my English brain was asleep.